This is the part 2 of this video. Now, in the part 2 of this video, they said if the flow rate is being increased by 50%, what is the impact on the frictional flow, the frictional factor, and the transmission factor? So now, that means if there is an increase in flow rate by 50%, that means we're going to multiply the flow rate with 1.5. So times the flow rate, and the flow rate is 3.5 mega meter cube per day. This should be equal to now. So now let's open our calculator to calculate this. So now with our calculator we have 1.5 times 3.5. So this gives us 5.25. So 5.25 times 10 raised to power 6 meter cube per day. So that is the flow rate we have now. Now, with this flow rate, we're going to calculate our real number. To calculate our real number, first let's write down the equation of real number, which is real number is equal to 0.5134 times the base pressure divided by the base temperature times gas gravity times the flow rate divided by the viscosity times the internal diameter. So we will now have 0.5134 times base pressure is 14.7 divided by base temperature, which is 288. Then the gas gravity is 0.6 times the flow rate is 5.25 times 10 raised to power 6 divided by the viscosity of the gas, which is 0.000119 times the internal diameter of the gas of the pipe, which is 380. So now let's make use of our calculator. Now, if you now use your calculator to calculate of 0.5134 times 14.7 times 0.6 times 5.25 exponential 6 divided by 288 divided by 0.000119 divided by 380. So we have 1.825 1.825 of 1.825 times 10 raised to power 6 let me check something. Yes, the other flow rate, the other Reynolds number is just something as 1.5 times the other Reynolds number. Let me divide this by 1.5 to see if I can get the same Reynolds number. Okay, same thing. So it's just the same thing as 7 times 5 times 1.5. You have this. So now, so this is the Reynolds number we're going to use to calculate our friction factor and the transmission factor. So, and we are going to use the Colobrex equation. So now the Colobrex equation to do this is 1 over the square root of f is equal to minus 2 log 2 base 10 bracket open e over 3.7d plus 2.51 divided by Reynolds number divided by square root of f. So so let me just write this again here. We have minus 2 log base 10 e over 3.7d plus 2.51 divided by Reynolds number divided by square root of f. So now if we take the inverse of of both sides, you have the inverse of 1 all over square root of f is square root of f. The inverse of this whole one is just 1 all over minus 2 log 2 base 10 e all over 3.70 plus 2.51 divided by Reynolds number square root of f. If we take the square of both sides, square both sides, you now have f to be equal to what? 1 all over minus 2 log 2 base 10 e over 3.70 plus 2.51 divided by Reynolds number square root of f brackets close then square. So we want to have f. So now let's say this is 2, this is 1. Or let's say this is we use different thing here. This is, let's say here is 1, here is f. Now we will assume f and solve for f1 and now compare the value of f1 and f to see if they are close enough. If the difference is approximately 0, no stop. So that is the logic on how to solve this, because this is an implicit function. So let's begin. Now, assuming f is equal to 0.01, so f1 will now be equal to 1 all over minus 2 log e. E is the value for e is 0.015 divided by 15 divided by 3.7 times 380, which is internal diameter, plus 2.51 divided by Reynolds number, which is 1.825 times 10 raised to power 6 divided by the square root of 0.01 all squared. So our f will now be to base 10 is to base 10. Our f will now be equal to, but now let's go back. Let's now invoke our calculator. We have now we have 0.015 divided by 3.7 divided by 380 plus 2.51 divided by 1.825 exponential 6 divided by 0.01 square raised to power 0.5 equal to this. So we'll now say log that will have minus this, so times minus 2. We have this, so we'll now get the inverse of it. So this is the inverse of it, then we'll square. This is what we'll get. We'll get 1.175. Sorry, not 1.175. We'll have f to be 0.01175. Let me write it down. Okay, 1175. 1175. 0.01175. Let me see again. 117522223. 223. So I've gotten this f, so it's far from this, so we're going to use this one now to, we're going to assume this f to be equal to this. So now assume f will be equal to 0.0175223. Now f1 will now be equal to 1 all over minus 2 log bracket open 0.015 divided by 3.7 times 380 plus 2.51 divided by 1.825 times 10 raised to power 6 divided by the square root of 0.011752223 square equal to. Now let's make use of our calculator now. It is to base 10. Let's make use of our calculator. So we have 0.015 divided by 3.7 divided by 380 plus 2.51 divided by 1.825 exponential 6 divided by 0.01175 223 raised to power 0.5, and then log times minus 2 times minus 2 inverse then square. So we have 0.0116540 we have 0.0116540 so that is this f. So it's different from this, so we're going to solve for another one. So we're going to assume our f is equal to 0.0116540. So now our f1 will now be equal to 1 all over 2 log 0.015 divided by 3.7 times 380 plus 2.51 divided by 1.825 times 10 raised plus 6 times the square root of 0.0116540 all squared. So this will now be equal to, let's employ our calculator. Now we have 0.015 divided by 3.7 divided by 380 plus 2.51 divided by 1.825 exponential 6 divided by 0.0116540 raised to power 0.5 log to base 10 times 2 minus 2 inverse then square. So we have 1165. So it's roughly 165. So it's 117. So 1165 90065 1165900 0.01165 900. Let me see. I'm not sure. Let me see. 1165900. So 900. So we look at it approximately. Now they are closer now, closely equal. So it now implies that f is equal to 0.0117. So this is the answer. So our f, which is the transmission factor, is equal to 2 all over the square root of f. So which is 2 all over the square root of 0.0117. So this will give us what? Now let's go back to this expression. We have 2 divided by 0.0117 raised to power 0.5. So we have 18.49. We have 18.49. Now let's calculate the difference. Now the impact when we increase by 50%. So the F when at normal flow rate is 0.0122. Now when increased by 50%, it now reduces to 0.0117 divided by 0.0122 times 100%. So let's look at the percentage decrease. So let's calculate the percentage decrease. So we have 0.0122 minus 0.0117. This gives us this. So divide by 0.0122 times 100. So it gives us 4.1%. 4.1% increase. Now let's look at the impact. So it's a 4.1% decrease. That is the impact. So now for F, here we have 80.45. So let's look at the value of F. This is 18.11. So now there's an increase. So say 18.49 minus 18.11 divided by 18.11 times 100%. So for F, this is for friction factor for transmission. So now this will give us what? Let's now calculate. Let me use a calculator. We have 18.49 minus 18.11 divided by 18.11 times 100%. So we have 2.1. So we have 2.1% increase for transmission. So this is the impact. Now we'll end the part 2 of this video. Now the part 3 will come soon. So let me end the part 2 here. Thank you for watching till the end. Have a nice day. Have a blissful weekend. Also do well to subscribe to my channel, hit the notification bell so each time I make new video you'll be the first to watch. Thank you and God bless.